Today is going to be 33-6. We're going to look at power reduction identities and even and odd identities. So you're going to use power reduction formulas to evaluate trig values and use even and odd identities to simplify trig values. So these are our power reduction formulas. The idea of a power reduction formula is somehow I need to transform cosine squared, and it looks like it turns into a double angle identity. The same goes for sine squared. The reason why we would want to use this is somehow for us to be able to eliminate squares or reduce squares. That's why we would want a power reduction formula. So look at this. What if I had sine squared theta times cosine squared theta? And I want to be able to reduce it down. Well, using our identities, we said sine squared theta was 1 minus cosine 2 theta over 2. And then cosine squared theta was 1 plus cosine of 2 theta over 2. Now when I FOIL this and multiply it together, I get 1 minus cosine squared. I did first, outer, inner, last, FOILed or distributed. 2 times 2, that gave me that 4. Now we're probably wondering, like, wait, I still have that cosine squared. And you're like, you're right. You're going to see how things simplify here. And so if I bring out that 1/4, and now I just have that 1 minus cosine squared, well, that's going to, if I distribute that through, that's going to be 1/4 minus 1/4 cosine squared 2 theta. This is also a power reduction formula. And so with that cosine squared, that's going to be 1 plus cosine of 2 theta. In this instance, we're saying theta is 2 theta, and so it's 2 times that what we plugged in, which is the 2 theta. The 2 times 2 theta gives me 4 theta. Now I multiplied this 2 here with this 4, and so now I have 1/4 minus 1/8. Add those together, or subtract those, and I get 1/8 minus 1/8 cosine of 4 theta. And that right there is going to be my result. It is no longer written as a square. Now these are our even and odd identities. If I have a negative inside of a cosine or a secant, it's the same as if there is no negative. If I have a negative inside of a sine or cosecant, it's the same as if it were on the outside instead. The same goes for tangent. So we need to know these identities as well. Now remember, this is like an even function. These are odd because they follow that pattern. For this one, f of x equals f of negative x, and this one is f of negative x equals negative f of x. So those follow that pattern there. So for this one here, use even or odd identities to verify the statement. Well, I know that since sine is odd, I can write it as if I have a negative on the outside and I pull out a negative on the inside. So you're not factoring it out, but it's almost like that. So then this becomes negative 3 pi plus 2 theta, which now I can rearrange and rewrite it as 2 theta minus 3 pi. Those are now the same. Fairly simple. So to close today's lesson, what did we learn today? Well, we talked about power reduction identities and even and odd identities. Very simple, very straightforward. Now, how do the even and odd identities relate to even and odd functions? I want to hear back from you guys and then tell me what the similarities are. This does conclude our lesson. If you have any other questions, please leave them in the comments.